So we started with, everybody ready? We started with this being T. So the load in this cable right here is T. What's the load here? 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 T. Okay, so what's the relationship between P and T? T is equal to 2T, right?
Yes.
Because if I had taken that pulley, that C pulley, I have P here, and I have T here, and T here. So I'll write up the full equation. Sum of the forces in the Y equals 2T going up minus P equals 0. 2T equals P. Okay, so now what's the cable in here?
3T.
3T, good. What's this?
3T.
What's this? Right? So what's W equal to? 9T. Got it? So what's the relationship between W and P then? Equals 9T, and T is equal to P over 2. So what is that, 4.5T? Am I off the page? No.
P.
Good? Is that right? Okay, there's a complication in this other one. So let's start. The complication is here. And the piece of information I need to give you is that the radius of, you see how there's 2 pulleys?
Yeah.
Where are my pulleys that are being passed around? So Aaron has it, remember one, did you guys see the pulley? Went everywhere? So one was more of a simple pulley where we were just looking at one pulley, but this was a combined pulley, so there's one in the front and one in the back. So radius 1 is 3 inches, and radius 2 is 6 inches. So before you start, let me just talk for a minute. We looked over here and said that for a statics problem, we're using an equation of sum of the forces is equal to 0, because we're saying it's not moving. Sum of the forces equal to 0, is that talking about not moving translationally, or is that talking about not moving rotationally? Just force. We're just looking at force. What is force? Is it a linear motion, right? If I pull you, Jose, right? I'm pulling you in a linear motion, right? It's not unless I apply a force off-centered that I'm actually going to create a rotational motion. So this has to do with the translational part. The rotational part is, do you remember in physics, what did you call it?
Torque.
Sum of the torques equals 0. But in engineering, we don't use the word torque. We use the word moment instead. They're synonymous. So I'm going to say the sum of the moments equals 0. So on these problems, on these pulley problems, we were looking at some of the forces in the Y equals to 0. But this pulley, let's see, it's pulley B and A prime, not, right? It's let's say position 2. Where position 2 is, that's a combined pulley system. So we're really going to be looking at this equation in addition to some of the forces in the X. Okay, so try it out. Start at T. Or, I mean, if you want, you can start at W2. Either way. Sure. In another direction, you have to dock.
Because it looks like it just goes around. And then Yeah.
Just to see what in the direction of that too.
Yeah, remember we
So basically, like, think about all the directions either on. So if I'm trying to, if I have a fulcrum, short lever on it, and I'm trying, then I'm can take more force. Do you remember like just like the math function?
Are you guys ready to go over it? Yeah? Okay, let's take a look up here. So, the force in this cable is what? T. The force in this cable is? T. The force in this cable is? T. Now, what's the force in this cable? 2T. Now normally, if it's a continuous cable and it's coming into and out the same pulley, then this would have been 2T, but it's not. So I'm going to draw the pulley. This one here is 2T. This is something going up here, and this guy is coming down here. So what's the distance here? I said that from here to here, and from here to here. Here to here, it's 3, and here to here, it's 6. So what we're going to do is sum of the torque, or sum of the moment about the center. So sum of the moment about that center point is equal to 2T times 3, positive. And then, whatever this is, let's call it, there's no P in here, let's call this P. Is everybody okay with me calling it P so we can figure out what it is? P times 6 equals 0, and P would be a negative. So that means 2T times 3 is equal to 6P. So what is P equal to?
T.
T. So 2T is coming in and T is going out. All right. What's this cable right here? 3T. So 3T is equal to W. So let's do that again. So everybody look up here. So we have T here. Same cable, T, same cable, T. This, looking at the free body diagram of the pulley with 2 T's going down, this has got to be 2T. 2T goes in here, if there's a cable coming out here, and because of the moments, because of the torque, the distances here are different, this turns out to be T. So we have, now if I look at this pulley right here, I have a T, T, and T. This must be 3T, so 3T is equal to W. So let's think of our situation with our 500-pound item here on the floor. It's going up a pulley, the cable is going up a pulley and down the pulley, and I'm pulling, and I'm going to have to pull 500 pounds. So what do I want to do? I either want to put a system of pulleys in, or can I put a pulley like this in? What part would the engine connect to, and what part would I want to connect to? I want to connect to the larger pulley, and I want the engine to be connected to the smaller pulley. Because then I'm using this combination of pulleys to decrease the amount of load I have. But I could also set up a system of pulleys, right? Take a look at this. If I have the engine block here, and I have a pulley, I have 3 pulleys, my load here is a quarter of the weight. So to decrease the amount of load I want to pull, I could either set up a system of pulleys, or I could set up a situation where I have this kind of pulley, a composite pulley. Chelsea?
Good on everything except for why the negative P.
Okay, so remember torque, and we haven't gotten into moments yet, and we're not going to actually get into moments for a couple of weeks, or at least a week. So I'm looking at this point right here, right?
Here's the direction.
Yeah.
Is that what it is?
So remember right hand roll, or you put the right hand up, right? So if my force goes like this and it's causing a counterclockwise spin, I have a positive moment. If a spin is created that's counterclockwise, I'm going to have a negative moment. Okay? So when I analyze this point, this load here of 2t is creating a counterclockwise moment, and it's positive. But this force, this weight, this tension coming down here is creating a clockwise moment, and it's creating a negative. So if we go back to, let's look at forces first. We're all comfortable with forces, right? If the T's go up, they're positive. If P goes down, it's negative. We're very comfortable with forces and directions. When we get to moments, we have a similar thing. We have to have a sign convention. Since forces are representing translational motion, we're comfortable with. If I move this way, it's positive. If I move this way, it's negative, right? But with moments, we have to decide. Moments are spins. They're rotational motion. We have to assign what's going to be a positive spin and what's a negative spin. And the sign convention for both physics and engineering and math, did you ever do right-hand rule in math? Okay, it's all the same. Counterclockwise is positive, clockwise is negative. So this 2t creates a positive moment on this point, and this force creates a negative moment. So 2t times the distance 3 is a moment, and it's positive, minus p times 6, and it's a negative moment. We're going to be dealing with moments a lot. Okay? And it's not rotating because in the end, the sum of the moments equals 0. It's not rotating. So now, I do want to assign 2 more things. So if you pull out your syllabus,